Hello, welcome again. We are covering GATE Aerospace Engineering Syllabus Section 1 Engineering Mathematics, and the core topic is calculus. In the calculus, next topic is chain rule and partial derivatives. So here we start with function of two or more variables. So uh, the symbol Z represents the function Z represents an equation or value which is a function of two variables for x and y. So this is represented by like this: f function of x and y, z is function of x and y. Okay. And limits of this function is just now it is dependent upon x and y, so limits will be written as limit x tends to a and y tends to b, and then we write function, and then this is limit, and uh, which either one can be solved first and then other can be solved. And continuity, a function is said to be continuous at point A and B if its limit and its value are same. So limit is limit x tends to a, y tends to b, fxy, and we put the value of x is equal to a and y is equal to b in the function, then the value comes out as f is. So if these two are equal, then the function is said to be continuous. Otherwise, it is a discontinuous function, like single variable. In single variable, only x was there. In double variable, x and y are there. Okay. And in single variable, limit x tends to a, f x is equal to f a. And in double variable, limit x tends to a, y tends to b, f x y is equal to f a b. So this is just extension of a single variable. Next definition is partial derivative. So we have z, which is function of x and y. So then if we keep y constant and differentiate z with respect to x, then it is called its partial derivative, and it is represented by curly z by curly x, or we can say it is curly f by curly x, or it is f x bracket xy. Simple function is f function of x and y, and differentiation, partial differentiation is f x bracket x comma y, or dxf. So these are the way to represent the partial derivatives. And the partial derivative is actually it is curl z by curl x is equal to limit x tends to 0. Here next step of x is taken. So function of x plus delta x and keeping y constant. Okay, y minus f xy divided by delta x. So that is the curl z by curl x. Similarly, if we take if we keep x constant and find out the derivative of z with respect to y, then we have partial derivative of y, which is also represented by curl z by curl y, curl f by curl I, f y bracket x comma y dy f. And this curl z by curl y is your limit delta y tends to 0. So this is f. Here y is increased and x is kept constant. So this is your f x comma y plus delta y minus f x y divided by delta y. So this is the limit of z. This is the partial differentiation of z with respect to y. So if we again if we differentiate this curl z by curl x with respect to x again, it will be curl square z by curl x, or it is written as f x x, or double differentiation of z with respect to x keeping y constant. Similarly, if we differentiate this with respect to x, then it will be curl square z by curl x curl y. It will be written like this, or z is replaced by f curl square f curl x by curl y, or it is, because first we have differentiated z with y, so we will write y first and then x. Okay, similarly, if we double differentiate this curl z by curl y, then it will be curl square z by curl y square, or curl square f by curl y square, or it is f by y. Okay, so now if we are taking this, it doesn't matter with respect to what we are differentiating first, or we can say curl square z by curl x curl y will be equal to curl square z curl y curl x. Okay. So it doesn't matter if we want to find out this curl square z by curl x curl y, it doesn't matter whether we differentiate z with respect to y first or last. Okay, so then this curl square z by curl x curl y is equal to curl square z curl y curl x. Okay. Now these symbols are used. Curl z by curl x is equal to p, curl z by curl y q by q, curl square z by curl x square by r, curl square z by curl x curl y s, and curl square z by curl y square c. Okay, so these are the symbols. Now total derivative is simple derivative. Suppose we have a function, we have a u which is a function of x and y, and further x is function of t and y is also function of t. Okay. So now we want to find out the simple derivative, not partial derivative, simple derivative that we express in the plus du by dt. Then this is the chain rule. We will differentiate with u with respect to x, because u is a function of u is a function of x and y. So we will first partially differentiate with respect to x, curl u by curl x, and then we will differentiate this x with respect to t, dx by dt, plus now this is partial differentiation of u with respect to x, this is partial differentiation of u with respect to y, and into dy by dt, or ordinary differentiation of dy with respect to t. That is the chain rule. So simple derivative is equal to du by dt curl u by curl x into dx by dt plus curl u by curl y into curl y by curl t. Just differentiate with one variable, suppose it is x, then differentiate this variable with respect to t. Okay. And here other variable, and then differentiate this variable with respect to t. This is your chain rule.